Welcome to We Learn. This is session number 6 of RDBMS on relational algebra. In this session, we are going to cover topics: basic notations of a relational algebra, fundamental relational algebra operations are select operation, project operation, union operation, set difference operation, Cartesian product operation, composition of operation, and rename operation. Now, the first of all, about the relational algebra, this is the basic set of relation model operation that constitute about the relational algebra. They are the operation that enable the user to specify basic retrieval of request. यहाँ पे यूज़र जो भी डाटाबेस से अपना इन्फॉर्मेशन एक्सट्रैक्ट करना चाहता है दैट इज रिप्रेजेंटेड हियर दिस इन द मॉडल हाउ टू वी एक्सट्रैक्ट द डाटा फ्रॉम द डाटाबेस using the arithmetic operation. So the result of retrieval is new relation which may have been formed from one or more relation. The algebra operation thus produce new relation which we can further manipulate using operation of the same algebra. Here a sequence of relation algebra operation forms a relation algebra expression. Basically, here the relation algebra operation are divided into two groups. That first group includes set operation from mathematical set theories that are applicable because each relation defines a set of tuples like union, intersection, set, difference, Cartesian product are these of first group, and the other group that consists of operation developed specifically for relational database. These include select, project, and join among others. So in this session we will study this operation. Now the basic structure in front of you, the slide is shown. That is given that d1, d1, d2 up to dn are the some sets of the relation, and we apply the operation on it. The relation is set of n tuples, means here are the rows from a1 to n, where each row is represented here by the ai that belong to di, means here the row that belong with the relation of di. And consider here the example of customer names, and its name are the shown in the braces here, and the customer street that is taken again in the braces here, the customer city that again shown here, that taken some city, and there is the relation between these of the tables in the columns, and a relation over the customer name, customer street, and customer city is the made here. Now let's see, there are some attribute types that we already discussed in last session. What is attribute in detail with the symbols and example. Now each attribute of a relation has a name, and set of allowed value for each attribute is called the domain of the attribute. Attribute values are normally required to the atomic, that is invisible, that is to be single. Note that multi-valued attribute values are not atomic, like here secretary and clerk. That is the example of multi-valued attribute position. And the one more thing is to be note here, that composite attribute value are not atomic because that are composed from the other one, and the special value null is the member of every domain. Next, the null value cause complication in the definition of many operation. Null values means that is empty, that you can say that is not known to the user at the time of entry. Example, you can say particularly phone number, if you don't know you will remain it empty. So such a null values in the table that such create the problems to extract the data from the database. Next is here shown in front of you, there is relational schema. Schema that already we discussed in the last session is the basic structure of table, and there are some attributes in the schema are the considered here. Up to A1 to AN are the attribute, and R is relation on this attribute is called here relation schema. Consider an example, a customer schema that take the customer name, customer street, and customer city. That in the previous slide we taken this three name example. So in this three we make the relation here between these three data, and R is considered relation name over the relation schema. So here customer schema is considered here of these three between these three tables. Now there is the relation instance that relation instance shows the what we consider here a current value, that is relation instance is called a current value of a relation that is specified by a table. Next, a table element T of R is a tuple that represented by a row. Let's see this diagram. In this diagram, that three column we consider here customer name, customer street, and customer city. We enter the data as shown in the first slide is in this table, and this show that these are row are called tuples, and this column are called here attributes, and the overall this is the customer table name that you say is the entity. This attribute also said can be said the attribute that we represent in ER diagram in the previous session. Next is the about database that consists of multiple relation. That is say the in the beginning introduction of database we discussed that consists of many of the table, and that is the consist of multiple relation, and information about an enterprise is broken up into parts, which each relation storing one part of information, like the account that store information about accounts, depositor that store information about with the customer owns with the account, and customer that store information about customers, that storing all information in a single relation such as like bank account number, balance, customer, they form the relation here. So the result in repetition of the information can be arise here because they are entering different table again and again. So the example, two customer own an account and the need to be for null values, the representing customer without an account. That is great, that can be create such amount of the problem with the help of null value that we need to be rectify. It should be very less as to be used is to be used. Next to be the query language that we will use to extract the data from the database. The query language, the language in which user requests information from the database. This language is further categorized in procedural and non-procedural. So about this is the relational algebra, that is of procedural language, and that is pure procedural language is relational algebra, and tuple relation calculus, domain relation calculus is in this language are come under the pure procedural language. So pure language from underlying the basis of query language are the people we use this relation algebra. Now the first word is what is algebra. The mathematical model consists of some operand and operator. As you know, in the mathematics we use the various symbol like plus, minus, multiply, divide, and you use statistics also, union, intersection, the various statistics operation you also use. So same we apply here also to extract the data from the database, and operand are those on which we are applying the operation, and the operator are the symbol that we are using between the operands. So let's see the slide that's shown here. The operands are the variable or values, and operator are symbols that denoting the procedure that construct new values from a given values. So a relation algebra forms a algebra whose operand are relation and operator are designed to do the most common thing. What we need to do is with the relation. This was the basic introduction of the relation algebra. Now we apply here some basic relation algebra operation. Now these are the operation that we apply here. The select operation, project operation, union, set difference, and Cartesian product operation. Let's see how we can use it very well. Basically, the select operation used to select a subset of the tuples from a relation that satisfy selection condition, and that one can consider select operation to be filter that keeps only those tuples that satisfy a qualifying condition. Here the way symbol use this symbol sigma we use to select the multiple rows, where the select sigma is used to denote select operator and selection condition in the Boolean expression that specify on attribute of relation R. Notice that R is generally a relational algebra expression whose result is relation, and the simplest expression is just the name of database relation. That's explained. We use this operation over the relation algebra expression to extract the rows from the database, and the symbol row that called the select predicate and defined as this. This is the select row. We are extracting the select from over the rows, and the taken the over the R, that is the relation from the table. Now where this row that formulate the propositional calculus consisting the term that connecting with this symbol and this symbol, this and the symbol this is used for or, and this symbol is used for not. Each term of that one of attribute OP, that attitude or constant, that operation that we will consider here, the between row operator or condition we can apply over the constant, where OP is one of like OP that we said the operator this can be considered here equal, not equal, greater than, less than, greater than equal to, and less than equal to. Let's take an example here. The selection here, the account number over the branch name and the balance. So operation we apply here, sigma we used here to select branch name, where equal to the package is the branch from the table account. This is the again an example that show how to extract basically extract the row over the value greater than 5. Similarly, that show how to extract data with this symbol. It consider this value table, and this table that this value are taken here, and this data here. This query that show the data is taken B and D, and that is greater than 5. The value of it extract the value that the B and D that contain the greater than 5 value, that is here the 7, 7, 3 and 5. We leave the 3 and contain out the 7, 7 value from this query over the relation here. Let's see here, the value was greater than 5, so it extract the value that is greater than 5 is the D, that is 7 and the 10. So select query that extract those rows that match over the condition here. And the project operation we apply here. In the project operation, we think that relation is a table, and select operation select sum of rows from the table while discarding other row. The project operation that other hand select the certain column from the table. जैसे कि अभी हमने पिछली स्लाइड में सिग्मा पढ़ा था, that was select rows from the table, and this project operation that extract the column from the table. Here in this project operation we use this pi symbol. This pi symbol we use to select the column, and over the project operation the attribute list is that extract a list of attribute from the relation R, and then again notice that R in the journal a relation algebra expression whose result is a relation. So simplest case we just name the database relation. Let's see there, this is the select we use here projection pi operation and select the column from the relation R, where A1, A2 so on are attribute and R is relation. The result defined as the relation K column obtained by erasing column that are not listed. Duplicate rows removed from the result. When we apply this project operation, the duplicated row are the remove and extract the distinct value. And an example is considered here to eliminate the branch name attribute of account here. Take the pi, the account number and balance column are taken out from the account table. if relation account contain 50 tuples, how many tuple contains here? That we can be use queries like this one. And if relation account contain 50 tuple, how many tuple contains? We can use like this the query. The pi and the balance and the quotient, that account and the quotient. This is the next example of the project operation we applied here. They taken this in this table relation R, A, B, C and are the column here. In this column we consider some data alpha, alpha and beta and some B value and some are the C value taken here. Now we extract the using projection operation here. A and C are applied here over the relation R. We extract column A and C from this relation R. So see the result, we get the A and C column. So but A and C column, you see here the value of C, that some value can be a repetition like A, that is 10 and the 1, and taken again alpha, that is 20 again the 1, and beta that contain B value 13 1, and beta again that value 40 and 2. So that the project relation set of attribute on the set of tuple. In this that you see there, the value extracted from the column of this value, that is repeated value again extracted from the alpha. It take only one value of alpha from the C. So in the result take only one value of alpha in the C, क्योंकि जब हमने इसमें कॉलम पे अप्लाई किया, कॉलम एक्सट्रैक्ट की, तो A और C कॉलम तो यहाँ से निकल के आ गया, बट यहाँ से जो डुप्लीकेसी वैल्यू ऑफ अल्फा की थी, यहाँ पे A1 दो टाइम रिपीट हो रहा था, तो इट टेक आउट ओनली वंस. So result that show here alpha that will be 1, beta 1 and beta 2 be represented here. Next is the union operation. As in the mathematically, I hope you already use over the union operation that in the statics, mathematical statics, that used to combine over the various operation. Using the union we can use here. In the union operation, consider here the relation that is represent in front of you, and there is a depositor. That example is considered in the depositor table, that customer name, account number, and the one more table consider here borrower, that contain here the customer name, loan number are the column in the borrower table. And the now the union operation we are applying over these two table. That union symbol is represented by the U here, that you can see easily in the table slide, that U symbol that represent the combination of R and S union. This is the R and S must have the same number of attribute to be combined over the table. And the second point, an attribute must be compatible. That example, that does the second column of S that to be matched to be union for the union operation. So the union operation yields the result that appear in either or both of two relation. It is binary operation denoted by symbol U. For example, consider query that will be find the name of all bank customer who have either an account or loan or both. In this way, like you can consider union example very well. To find the result, we need two information in depositor relation and borrower relation. To find name of all customer with the loan in the bank, we would write such kind of example taken the query to extract the union operation. We take here the all customer either account or loan. This is the taken here to consider customer name from the depositor table, and that is union apply with the customer name from the borrower. That relation that denote, and we define this in the mathematical form like this way, that R union S, and this is the all row that extract from the relation R and that belongs to the set S. R and S are the different relation. Next, this is shown as the union operation once more here. You can see easily these two table R and S. The union represent the combined form of these two. Here you see the alpha 1 is combined taken from this R relation. Alpha 2 is again here R2 as well as in S also. So it's not repeated again. Next is the beta and 1. that is taken here from R, and beta 3 is again that different in S is again taken here. So this is the show the union relation over the R and S. Next is here the set of difference operation we will apply here. For the set of difference operation, you will see this difference denoted by the symbol, this minus symbol that represents set of difference operation. The result in finding tuple that are in the one relation but are not in another. So there the expression R minus S that result in the relation containing those tuple in R but not in S. So they are the condition that represent here the set difference must taken between compatible relation. R and S must have the same number of attribute, and attribute domains of R and S must be compatible. This is the example that's shown in front of you of the difference. Let's consider here the two table again. This is R and this is S. And again we apply R minus S, that is difference operation we apply here. So it removes all the value that is belong in the S and show the value in the R. Like here the value of alpha 1 and alpha 2 alpha 2 is also in the S also. So it will extract the remove of alpha 2 value. It consider alpha 1 that is not in S and beta 1 that is also not in S. The result is shown here, the difference operation applied here. Next is come here the Cartesian product. The Cartesian product of two relation that is denoted by the cross that written like show in the front of your slide notation R into S. The relation, this is the new relation with the tuple. For each possible pairing of tuple can be formed for the relation R1 and R2. In order to avoid ambiguity, the attribute name have attached to them to the name of the relation from which they came. Now if no ambiguity will result, we drop the relation name. Now here they assume defined as the how we can find Cartesian product that is shown in front of you is the slide R cross S, and this is the that show the all the tuple that relation with the belong R and the Q that belongs to S. So that assume that attribute R and S are disjoint and that taken out from this relation, and if attribute of R and S are not disjoint, then renaming must be used here. This is the example taken of Cartesian product operation. The table here R and S consider here. R contain this value and S contain this value. We make the all possible number of combination can be make here. Let's see there R into S means R that alpha 1. First combine all the possible form with the S. See here alpha 1 is combined with the here alpha 1 and beta and with the gamma. That you see here alpha 1, alpha 1, alpha 1, alpha 1 repeated as the number of combination here in the this table of S till gamma. Next taken here beta 2. Beta 2 again repeated many of time till of the all value are cover of S. Again from alpha to gamma combined with the value of beta 2 here. So this kind of representation that extract from the Cartesian product from the relation R and S. Next is here the composition of operation that can be built with the expression using the multiple operation that can be composed over multiple operation, like we apply here select as well as Cartesian operation. In the select we extract the particular rows, that is apply condition here A equal to C, and also as well as Cartesian product also applied here. So in this relation you see here first the Cartesian product apply the result shown in front of you. After that it match the select query that check over the A and equal to C value. So it extract those value that will be equal to them and show the result here. So this is the composition of operation. Next is the rename operation. The rename operation involve that solve the problem that occur with naming when performing the Cartesian product of a relation with itself. That suppose we want to find the name of all the customer who live on the same street and in the same city as Smith. Can we take an example here Smith, and you can say in the front of you in the slide shown here, allow us the name and therefore to refer to the result of relation algebra expression, and that allow us to refer to a relation by more than one name. Consider this example, this row and that is the apply here the operation over the E. That E is the expression under the name cross, and the relation algebra expression E has an arity and n. That is to be applied like this. We use the like this expression, and there are the name that we apply rename operation over the E expression, that return the result of expression E under the name over this cross symbol, and the attribute name are this A1 to AN. Next, there is a consider a example sum where we can apply to extract data over this example. So consider here the branch, that in the branch table they taken the branch name, branch city, assets. One more table here, customer name, customer street, customer city contain in the column customer, account table that contain the account number, branch name, balance are the column in the account, loan in the loan table take the loan number, branch name and amount column the loan, depositor that take the customer name and account number in the depositor, and the borrower that take the customer name and loan number. These are the table. Consider an example here, and we apply the query over this. First need to be about the key before to apply query. In the key there the P belongs to R. Here the key are the super key of R. If value of key are sufficient to identify a unique tuple of each possible relation R. By possible of R, we mean a relation R that could exist in the enterprise we are modeling here. Consider an example, customer name, street and customer street apply here, and the both super key of customer, if no two customer can possibly have the same name. So key is the candidate key, and the minimal of the example taken there, customer name is the candidate key of the table, and the primary key that is the unique key on the table that cannot be repeated again of anyone again, like say the roll number that is not to be repeated again, the same roll number cannot be assigned to another student also. This diagram that represent what is the super key and the candidate key. The super key contain the large of number, and between them there are some of the candidate keys, and these are the example of the queries. Let's see that find all loans of over the $1200. Now we extract the rows. It use the select sigma symbol, amount greater than 1200 from the table loan. The query should be, I hope, very clear. Find all means you are taking loan that from the table loan, those value greater than $1200, means the rows you are extracting means amount, row column is the amount, the value match greater than 1200 from the table loan. Next query here, find the loan number for each loan of amount greater than $1200. Now let's take out the column that is loan number, and in the column that again apply the select query, amount should be greater than 1200 from the loan table. Next query or example here, find the name of all customer who have a loan, an account or both from the bank. So here to consider example, this the pies projection symbol apply here to extract the column from the borrower, and union apply from the customer name from the depositor table. And the next query, find the name all customer who have a loan and an account at bank. That means should be common in both the table. So we use here intersection symbol, the customer name in the borrower as well as customer name in depositor. This is the exercise that you can try it by yourself, that explain the Cartesian product operation, and the second question that explains select and projection operation with example. That's all about today's session. We are now winding up here. Thank you so much. Happy learning. We learn.